I just built one of these PLL feedback oscillators, and I'm trying that for the first time, but thought that was pretty cool. This coil right here is pretty much the only one I've got that's suitably in the range of this circuit. That's Steve Connor's PLL driver. So you can see it's basically just a basic half bridge. You've got your gate drivers and then the PLL chip right here, which is your feedback oscillator. Now, I'm just coming out with the antenna, and really you just have to get your phasing right. And then when I cut the power up, you can see those are the kind of arcs that it comes out with. So as far as tuning the primary and all that, I'm not real sure, you know, what the outcome there would be. But, well, first of all, let me cut it up a little bit. You can see over there, this is at about 490 kilohertz. In this circuit, so it's once I start cranking it up, you see that light comes on and it starts oscillating pretty much immediately. So that tube gets going just a little bit. It's kind of hard to see, and you know, I've just barely cranked the variac, so the tube comes on like right there. So it starts oscillating very early, and then right about there I hear some sparks, about 25 volts. So about 50 volts, you see some action. But just to kind of show, you know, again, what's making the shape of the arcs is the voltage envelope. So it's just interesting to see all these various feedback methods and how the arc changes. Now, I have tried staccato. I've made a couple staccato drivers. The first one I tried, it seemed to work, and then I looked at it on the scope and I noticed that it was all funky. You know, it was syncing, it was finding the zero crossings, but the on time, number one, was not synced up with the zero crossing, and then it was staying on for like 7 milliseconds, something like that. So it was not an ideal ramp. It was staying on for the whole duration of the half cycle, and I want something that's basically quarter wave. So I made another staccato circuit, identical one, just to see, and it works identically. So while I haven't quite figured that out yet, it does change the arcs a little bit, makes them more sword shape. I mean, obviously you can interrupt it, but it didn't really make them longer in my case, so I got to work on that. But again, this feedback oscillator just has a potentiometer on it, and you can see how the arc changes as I vary the knob on the CD4046. There's a point where they start to look more sword shaped. If I just cut it up a little bit, you know, and try to pull arcs from it. So anyway, you know, it's got sort of like the normal half-wave looking discharge even when you're pulling the arcs, but they don't, as you're pulling them, you know, they don't tend to kind of thin out at all or start to crackle the wrong way. I mean, you can tell it's really staying locked on there. So again, that was just a random test setup that I threw together, but I thought that was pretty cool. You can incorporate that various ways. I mean, so the way this is, you know, it's got a couple gate drivers on Steve Connor's schematic. He's just got them tied to VCC, but which is what I've got them right here. But I can just take that off, and so I would run the enable pin input there out to the staccato controller if I wanted to interrupt it like that, or if I wanted to, I'd imagine if I wanted to complicate it, then I'll have to throw a bolt caps on there basically, and then interrupt it using my own interrupter. That'd be another way to do it. But yeah, PLL, pretty cool. Just throw the antenna out, and it wasn't fussy at all, really. Didn't have to play with the length of the antenna or how far it was. I just basically hooked it up, cut my voltage up to about 30 volts or so, and started cranking the knob until I saw it start oscillating. And then, you know, one way it didn't work, so I flipped the polarity, and that was it. So yeah, pretty cool. Just to show, here's the staccato hooked up. So the way I've got this is half wave rectified. If you full wave rectify it, then you know, it doesn't matter how your staccato's hooked up. But I've got this half wave, and so I've just got a plug over there, a 2-prong plug. So I'll just take the plug and flip it around. It's one of those cheapo 2 pins. So it's plugged in the right way, and I'm locked to the 60 hertz half wave. But the thing is, I've noticed that playing with this thing, in order to get the trick when you get the long breakouts, it's sort of like a combination of getting the lock in just right on the PLL, getting your tuning just right, and then making sure your staccato works right. But I was over here trying to, you know, mess with it at lower voltage, and I realized, oh, well, so you basically have to turn it all the way up. I guess what happens is the PLL will lock on just in a certain way. Charges aren't quite as long with that. It's kind of hard to see with that tuning, but I basically cut it all the way up, and then I'll back the pot a little bit. So you can hear that tone change. Basically, I'm changing the frequency on the PLL. See, my antenna just fell down. But yeah, I can see with a proper working staccato that's tuned just right. You know, the on time is kind of wonky. And then you get your PLL set just right. I might have to modify this one. Then I can see how you get the kind of ramped up cheating discharges. You know, but even with this basic setup, again, this seemed like a real easy way to get about 8-inch arcs there.